Okay, hello everyone. In a new video. On this one we are going to solve an exercise related to electricity in the chapters of resistors, electric power and energy, and AC voltage. This exercise was a previous one in the Brevet exams in 2013 first session, second exercise. The title of this exercise is water heater. A water heater is formed of a water reservoir equipped with a resistor D of resistance R. Part 1. Determination of R. Number 1. The resistor D transforms the electric energy received into another form of energy. Give the name of this form of energy. So here they are asking me about the role of the resistor. We know that the resistor transforms electric energy into thermal energy. Then this form of energy is given by the thermal energy. And the thermal energy, which is known as the heat energy. And this is known as the Joule's effect. Now in number 2, the characteristic current voltage of the resistor D is one of the adjacent graphs, figures A and B. They mentioned figures A and B, then now we can use them. Part A, the graph of figure A doesn't correspond to the characteristic of D, justify. Knowing that D is a resistor, then the characteristic current voltage curve must be a straight line passing through the origin. Referring to figure A, the curve, although it's passing through the origin, but it's not a straight line, therefore figure A doesn't correspond to the characteristic of D. Then let's say in part A, since the characteristic current voltage curve is not a straight line passing through the origin, and knowing that D is a resistor, then curve of figure A does not correspond to D. For this reason, figure B corresponds to D. And notice that in figure B, the curve, this is the curve, it's a straight line passing through the origin. Now in part B, they are telling me show using the graph B that R is equal to 50 ohms. Now this curve is being plotted in a system labeled by the current and the voltage. Therefore, knowing the current and knowing the voltage, we can calculate the resistance R, and this is done using the slope method. Then the slope method consists of 4 steps. The first step is given by writing the definition, and it's given by the resistance of the resistor is equal to the slope of the characteristic current voltage curve. Now the next step is to choose 2 points belonging to this curve. Then let's choose, this is the point A and this is the point B, say for example. Now let's label the coordinates of the point A and B. Now the point A has an electric current given by 0.1 amperes and 5 voltage, then or volts, 0.1 amperes and 5 volts, whereas the point B has the following coordinates, 0.3 ampere and 15 volts. And the next step is to convert these units to the SI, but already they are in the SI. And notice that always we write the current, then the voltage, current and then the voltage, and always in physics all numbers must have unit. Here notice that this number don't have any unit because already the unit is labeled here. Now let's calculate the resistance R, which is given by the voltage of the point A minus the voltage of the point B over the current of the point A minus the current of the point B. Now the voltage of the point A is given by 5 because 5 has the unit of volts, minus the voltage of the point B, which is given by 15, divided by the current of the point A, which is 0.1, minus 0.3. Plugging this on the calculator will give me 50. Since everything in the SI, so the value of R will be in the SI, which is ohms. Then the resistance R of this water heater is given by 50 ohms. Now, part 2 of this exercise, consumption of the water heater. The water heater functions normally under an alternating sinusoidal voltage of effective value U is equal to 220 volts. Then this water heater is equipped with a resistor R of resistance 50 ohms and is connected directly to a voltage source, giving an effective voltage or applied voltage of 220 volts. Part 1. Show that the expression of the electric power consumed by the water heater is given by P is equal to U squared divided by R. Then we need to prove that the electric power is given by P is equal to U squared divided by R. So how do we prove this relation? We always start from the general form, which is given by P is equal to U times I. And here, since we are calculating the electric power across the water heater, which is resistor D, then we can apply Ohm's law because R appear in the equation. Now, comparing these two forms, we notice that I doesn't appear in P is equal to U square over R, which means that we need to get rid of I, which is given by U divided by R. Now, replacing I here, so we got U multiplied by U divided by R. Now here, because it's a combination between multiplication and division, we can get rid of the bracket. Then U multiplied by U divided by R. U here is divided by 1. And this will give me U squared divided by R. Then P is given by U squared divided by R. And in the same part, they are telling me deduce the value of P is equal to 968 watts. Deduce means that we need to use the part just previously before. In this part, we have determined the expression of P, which is given by U square over R. Then P is equal to U square over R. Knowing the value of U, which is given by 220 to the power 2, we don't forget to the power 2. And dividing by the value of R, which is given by 50, plugging this on the calculator will give me 968. Since everything is in the SI, so the value of P will be in the SI, which is watts. Then P is equal to 968 watts. Now, in number 2, they are telling me calculate in kilowatt hours the electric energy consumed by the water heater during 5 hours of functioning. Then here it seems that we are calculating the electric bill. Then let's write here the steps of the electric bill, and they are given by 4 steps. So step number 1 is to convert P to kilowatts. Step number 2 is to calculate the electric energy E1 consumed per 1 day. So this is for 1 day. Now step number 3 is to calculate the monthly consumption or the electric energy per month. And finally, step number 4 is to calculate the cost. Now back to part 2, they are telling me calculate in kilowatt hour the electric energy, and we know that the formula of the electric energy is given by E is equal to P times T. We are calculating the electric energy for 5 hours of functioning corresponding to 1 day, so E1. Here they are telling me calculate in kilowatt hour. Kilowatts hour can be decomposed into kilowatts multiplied by hour. So the electric power must be in kilowatts and the time must be in hours. Knowing that the value of P is given by 968 watts, so we need the value of P to be in kilowatts. In order to convert from watts to kilowatts, we simply divide by 1000. Then dividing P by 1000 will be equal to 0.968 kilowatts. Then in this case the electric energy E1 is given by P times T. Now the power is given by 0.968 and the time is given by 5 hours. Now plugging this on the calculator will give us 4.84 kilowatts hour. So the electric energy E1 consumed per 1 day is given by 4.84 kilowatts hour. And here we are done with the step number 1 and step number 2. Now in number 3 of this part, they are telling me the water heater functions for 15 days in a month at an average rate of 5 hours per day. Then in this case the number of days is given by 15. Then in part A they are telling me calculate the electric energy consumed by the water heater during 1 month. So we already know the electric energy consumed per 1 day. In order to determine the electric energy consumed per 1 month, we simply multiply by the number of days. Here we are calculating the monthly consumption. And the monthly consumption, which is denoted by E, is simply equal to E1 times the number of days. Here in part A they didn't specify in which unit we should calculate the electric energy, but since in part 2 we have calculated the electric energy in kilowatt hours, and in part B we will calculate the electric bill, therefore we will determine the electric energy consumed per 1 month in kilowatts hour. Then the value of E1, which is given by 4.84 multiplied by the number of days, which is 15, plugging this on the calculator will give us 62.6 kilowatts hour. Then the electric energy consumed per 1 month is given by 62.6 kilowatts hour. Now finally in part B they are telling me deduce the monthly amount to be paid by the consumer, knowing that the average cost of each kilowatt hour is 100 Lebanese liras. And deduce means that we need to use the part just previously before. In part A we have determined the monthly consumption. In order to determine the monthly cost, we simply multiply the electric energy consumed per month times the price. The electric energy consumed per 1 month is given by 72.6 multiplied by the price, which is 100. This will give us 7,260 Lebanese liras, because the cost is in 100 Lebanese liras per kilowatt hour. So the price or the cost is equal to 7,260 Lebanese liras. And by this we have finished solving this exercise. Hope it was beneficial for you guys out there watching it, and see you soon in another one.